Okay, this is a section 11.8 complex fraction. A complex fraction is a fraction with another fraction or a mixed expression in the numerator, denominator, or both. So here are some examples of fractions. As you can see, here we have one large fraction, and then we have a small fraction 1/3 of the numerator, and we have another fraction in the denominator. Same thing for the second one. And here we have, a fraction, a fraction, a fraction, all over another fraction. So these are what we call complex fractions. So there are two methods for simplifying complex fraction. The first one is just apply the order of operations. The second method is you determine the LCD of the fractions that are in the numerator and the denominator. In other words, every fraction of that complex fraction. And then you multiply that LCD. So let's look at that. So here we have a complex fraction. And here's my steps. I'm going to combine each mixed to form a division of two simple fractions. So right now we're just doing the first method, applying the order of operations, all right? So this is what I've done here. I've taken it and I've combined each mixed to form a division of two single fractions. So I'm still in the process of making it into two single fractions. Notice that here we had 1 plus 1/3. Well, 1 I can write as 3 divided by 3, which is what I've done over here. And I did that, so now on the top here, on this one right here, I have common denominators. And then on the bottom, I wanted a common denominator. So I had to write this 5 with a common denominator of 4. So you would do that by taking 4 over 4, right? And that's going to give you that 20 divided by 4. So now on the bottom, I have two fractions with a common denominator. And now I can add straight across because 3 plus 1, put it all over 3, and 20 minus 1, put it all over 4. Go ahead and simplify, and I get 4/3 all over 19/4. So now what I have done is I've combined each mixed to form a division of two single fractions. The first single fraction is 4/3. The second single fraction is 19/4. So once I've completed that, then I'm able to write that complex fraction side by side as a division problem. In other words, I'm going to write this as 4/3 divided by 19/4. Remember, this is a division bar. It's the same thing as the division symbol. So now I'm just saying 4/3 divided by 19/4. Well, you all know the rules for dividing fractions. You can take and turn that fraction into a multiplication problem, right, by inverting the divisor. So that's what I've done here in this next step. I changed the division to multiplication, and I inverted this fraction by making it 4/19. And now follow your multiplication rules and just multiply straight across. So 4 times 4 is going to give you 16, and 3 times 19 is going to give you 57. So we now have simplified this fraction by just following the order of operations, right? So in other words, I'm looking again just one more time just so that you can kind of see this, because I may have gone through this, maybe you're not following along, I don't know. It's hard to tell because I can't see your beautiful faces, right? So basically they took this top and they changed this to have a common denominator, so then that you can then add them together and get 4/3. Same thing here. They took the bottom, they just treated it like a separate problem. They converted that 5 into a fraction with a common denominator of 4. Then they combined them and added them. So it's just that simple. They're just following there. And once then we have these into two single fractions, then we can write it as a division problem, then change the division and multiplication, and invert the fraction. So that's the method of applying order of operations. All right, so now here we have a complex fraction. The direction says use the order of operations. In your homework, it's going to tell you what method to use. So this one's saying use the order of operations. So the first thing we're going to do is we're going to combine each mixed form of division into two single fractions. So let's just look at the numerator first. Here's the numerator. We have x plus x over 3. So think of that as x over 1 plus x over 3. To get a common denominator, I'm going to have to multiply this by 3 over 3. Right? Then looking at the denominator, all right, we have the fraction 2 divided by x plus 5. So here think of this as 2 divided by x plus 5 over 1. I'm going to multiply this by x over x in order to get a common denominator. And so that's what I've done here. So naturally then you end up with 3 plus x all over 3, or you get 2 plus 5x all over x. So that's how we came up with those there. Then you're going to simplify if you can. If you look here, right, 3x plus x is 4x. And then 2x plus 5x in the denominator, you can't add them or combine them. They're not like terms. But now you've got two single fractions being divided, and now you're ready to go ahead and take that complex fraction and write it side by side. So that's what I'm going to do. I've taken the 4/3 x, this division symbol here, we've just changed it into this type of a division symbol. Then from there you can invert the divisor, that's the second fraction, and multiply, which was what we've done here. Then you can multiply straight across, and you end up with 4x squared on top. And then remember, this is 3 times all of this. So you have to take the 3 times the 2 to get 6, and the 3 times the 5x to get 15x. Then you're always going to ask, can you reduce by any cancel of common factors? Well, you can't factor the numerator denominator to have any common factors. So this one here, step 4, didn't apply to this particular problem. But let's look at step 5. Step 5, it says set each denominator factor equal to 0 that does not appear in the final denominator solved in each equation. So let's look at our original. So now we have to go back and we have to look at our original equation. All right, well, our original equation, right, there is an x in the denominator, right, in the original one that we started with. And that's true for us right here, right? There is an x in the denominator. All right, looking at so this is the original. This is what we ended up with. And there isn't an x in the denominator here as far as the denominator goes. Yes, there's a 15x, and if you plug in any number for x, you're still going to get a number. There's no way that this is going to end up being 0. Now, if you plugged in 0, right, then 15 times 0 is 0, but 6 plus 0 is 6. So you're not going to get an undefined no matter what number you plug in for x here. So it's not the same. But here, if we had plugged in a 0, 2 divided by 0 plus 5, well, this is undefined. Okay? So that's why they're concerned with the original equation. So in the original equation, you have to, x was not included, so you have to say that x cannot be 0. So you do have to write those excluded values where x cannot be 0. And you're really only concerned with that original equation. All right, that shouldn't be showing up, but let's go. Here we go. We've got this particular fraction. There we go. Sorry, something wasn't showing up for us. Okay, the second method. The second method is called finding the LCD, that's the least common denominator of the fractions, in the numerator and denominator of the complex fractions. Then you're going to multiply both numerator and denominator of the complex fraction by the LCD. So this is the second method. So we have two fractions, right, in our complex fraction. We have the fraction 1/3 and 1/4. So that's where I'm coming up with these. Those are the fractions that are in our complex fraction. And so I'm going to then find what is the LCD. Okay, well the LDC, we have 3, and we have, this would be considered 2 times 2. So technically our LCD is 3 times 2 times 2, which is still the same thing as 12. So, but most of you, you know, because those are so simple numbers, you would know that the least common denominator of 3 and 4 is 12. So this is our LCD. We're going to take that LCD 12 and we're going to multiply it. So we're going to take 12 and we're going to multiply 12 to this and 12 to that. That's what we're doing here. And then we're going to go ahead and simplify, right? 12 times 1 is 12. 12 times 1/3 reduces to 12/3, right? And 12/3 is the same thing as 4. And then we're going to take 12 times 5 and get 60. And then 12 times 1/4, which is the same thing as 12/4, which reduces down to your 3, right? So that's all we're doing so far. So we just multiplied. We're going to go ahead and simplify. 12 plus 4 is 16, and 60 minus 3 is 57. And if you notice, this is the same problem that we did on the first method, and we're getting the same answer. So both methods are giving us the same answer. And of course, you're going to ask yourself, can you simplify? Can you reduce? You know, and normally, if there was a variable in there, you would say, you know, what values need to be excluded. But in this case, we don't have any variables, so we don't have to. So let's look at this example. Here we're going to simplify the complex fraction, but we're going to use the LCD method. All right. So we have two fractions, right? We have the fraction x divided by 3 and 2 divided by x. And we're going to look at those and we've got to come up with the LCD, right? Well, if I'm finding the x, so we have 3 is prime and x is prime. Therefore, our LCD is going to be 3x, one of each. So that's our LCD of this complex fraction. We now are going to multiply both numerator and denominator of the complex fraction by the LCD. So that's what I'm doing here. And we're going to go ahead and distribute. So 3x times x gives me 3x squared. And think of this here, when we multiply this here, we're getting 3x squared over 3. Sorry, and the 3's cancel out, and you're left with x squared. Same thing here, we're taking this times this. Well, think about that. That's going to give you 6x divided by x, so they cancel out, and you're left with 6. And 3x times 5 is 15x. I'm not sure why we got a minus sign. I'm going to pause for a minute because we shouldn't have a minus sign, so that might tell me I might have did a typo. Hang on. Yeah, that's a typo. That should be 6 plus. All right, 6 plus 15x. From here we simplify. If you look at the numerator, we have 3x squared plus x squared, so that's going to give me 4x squared. You can't simplify anything on the bottom, right? Then it says, the next thing we're going to do after we've simplified, because that's what we've done, we're going to set each denominator factor equal to 0 that does not appear in the final denominator. Of course, you can always see if you can reduce. Okay, I should put that step in there. So set each denominator factor equal to 0 that does not appear in the final denominator and solve each equation. All right. So when we're looking at this, what is the denominator in the original equation? Well, it's x, right? X as a denominator is not showing up in our new fraction. It's x times a number, but it's not as a denominator. So in this case, you're going to say x cannot be 0, and you're going to have to write that excluded value. Okay, now basically, although both methods may be applied to complex fractions, the second method using the LCD is most efficient. Also, this is the second method that you will be using when you're solving equations involving rational expressions. So basically, they're saying the LCD method is the better of the two. So here we have a complex fraction, and we're going to use that LCD method again. Now, what's interesting is in the numerator we have two fractions. We have this fraction and this fraction, and in the denominator we have one fraction. So when you go and you are finding out the LCD, you are considering all three fractions, right? So in the numerator we have two fractions that we're considering. So here's the denominator, here's a denominator, and here's a denominator. Now we have to determine the LCD. So again, the LCD is going to be the x plus 1, and then this is listed once in each case, and so with the x minus 1. So this here is our LCD. We're going to multiply that LCD times the entire fraction. So here it is. I'm writing the LCD on the top and the bottom, and then I'm going to take this fraction here, right, and plug it in, put it in over there, because we're multiplying it. So I notice I've just taken this and I've just put parentheses around these. That's all I'm doing over here. All right, because I need to indicate that this entire LCD is being multiplied to everything in the numerator and everything in the denominator. Now that we've done that, we're going to go ahead and simplify or multiply. All right. So this is fun, isn't it? Okay, so the first thing that we're going to do, how can I show this to you? I'm not sure if I showed it to you in the next example. Let me see here. No, I didn't. All right. So let's think about this. If I take all of this and I multiply it times the 1, because think of this as this over 1. All right. This over 1 and then that. So what happens is these cancel out, right? And you're left with the x minus 1 times 1. So that's where they ended up with this. All right. And then let's look at the second fraction that's here. All right. Again, think of this as this over 1. This whole thing is being multiplied to this fraction. So what's going to happen is this x minus 1 and this x minus 1 cancel out, and you're left with a negative x plus 1. Okay, so notice I have to bring down this negative, and then I have my x plus 1. That's why I got that right there. And they're doing the same thing then for this one. Think of this as a fraction over 1. Think of this as over 1, right? So if you multiply this top numerator times that 1, you're going to get the same thing, right? Which is what they've got right here. Then for the second fraction right here, right, they're taking this. This is going to end up on top, and so now we're going to cancel out the x minus 1, and you're left with the x plus 1. That's how they got that right there. I'm hoping you're getting it. I think what I'll do is I'll do this second fraction just so that you can see. If I was to multiply this out, this to this, you end up with 1 x plus 1 times x minus 1 all over x minus 1. So see, that's what I'm canceling out when I'm saying that they were getting that x plus 1. So hopefully you kind of can visualize or see that. All right, now we're going to simplify. Looking at the numerator, remember there's a negative here. We have to distribute this negative. All right, so we can make this a plus minus, distribute the negative, and you get a negative x, and then a negative times 1, and you get a negative 1. Then you're going to do the FOIL on these two parentheses right here, and hopefully you recognize that's a difference of squares. So hopefully you could come up with the solution real quick. And then of course this is prime, there's nothing to do. And then we're going to go another step. Again, we're still simplifying. All right, we've got the x minus x cancels out, and then negative 1 times a negative 1 minus 1 is a negative 2. Right? Here on the bottom, again, we're simplifying. We end up with the x squared. The minus 1 plus 1 cancels out, and so you're left with the x squared plus x on the bottom. And if you can reduce this fraction by factoring and reducing and canceling, you would. Okay, in this case you can't. But now what we want to look at is what would be our excluded values. We want to look at the original. So here's the original. This is the original. What was the denominator in the original? X minus 1. Is x minus 1 in this denominator in our new one? No, it's not. So you're going to have to do that where, and you could factor out an x just to double check, by the way. So I factored it. I guess you could factor it. So anyway, so you're going to take this x minus 1 right here, solve for x, and x cannot be 1. So then you write your excluded value where x cannot be 1. All right. So I wish you well with these. You may want to come back and rewatch the video again. If you get stuck, feel free to call me, text me if you need to see any problems worked as you're doing your homework. I know complex fractions can look a little scary, but if you just do one step at a time, write your steps out, I think that will help you as well.